Hello friends, today's question. A uniform circular disc of mass 50 kg and radius 0.4 meter is rotating with an angular velocity of 10 radian per second about its own axis, which is vertical. Two uniform circular rings, each of mass 6.25 kg and radius 0.25 meter, are gently placed symmetrically on the disc in such a manner that they are touching each other along the axis of the disc and are horizontal. Assume that the friction is large enough such that the rings are at rest relative to the disc and the system rotates about its original axis. The new angular velocity of the system is. So we are given a disc. Okay. So let us draw. Suppose this is the disc and it is rotating about the axis and which is given as vertical. Let us suppose it is having an angular velocity of omega I and which is given as 10 radian per second, and its mass is given as 50 kg and angular velocity is given as 10 radian. In the second part, two circular rings are placed on this disc. So this is the disc and this is the axis, and that circular rings are placed such that these two circular rings are touching each other. So this is one circular ring and this will be the other circular ring. Okay, so let me draw the top view of this. So the circular disc from the top will be seen like this, and this will be the axis, vertical axis, and similarly for this part, if this is the diameter and this is the axis which is vertical, now these two rings are placed like this. They are touching each other, it is said in the question itself. Okay. And this is the disc on which it is rotating. So in this case, let us assume that the angular velocity with which it is rotating is omega f, and we are given, let us suppose the mass is capital M and radius is capital R, and for the circular rings the mass is small m and the radius is given as small r. Both are same, so let us only discuss only one part. So we can say this is our initial condition, and this is our final condition. And we are supposed to find out the angular velocity omega f when the two rings has been placed on it. So let us consider first case when only circular disc is rotating. So for initial condition, we can find out that, let us suppose this axis is called as xx prime. Okay, so this axis will be still xx prime, and the axis of this ring, let us call this as yy prime. Okay, and this will be the radius of the ring having a mass small m, and this will be the radius of this disc having a mass capital M. So in the initial condition, the circular disc is rotating about the axis xx prime. For initial condition, you can say the circular disc is rotating about axis x prime. So we can find out its moment of inertia. Therefore, moment of inertia of circular disc about axis x prime, and let us call this as I initial about axis x prime, and which will be equal to half mass and its radius square. Okay. So this is the standard formula for the circular disc. Now, in the final condition, for final condition, we have a circular disc along with two circular rings. Okay, so we have uniform circular disc which is rotating about axis x prime, and we have, so in this case also, its moment of inertia of circular disc about axis x prime will be given as let us suppose given as final x prime will be once again half mr square. Now we concentrate on the rings. We can say that the rings are rotating about the axis y prime. Okay. So initially they are rotating y prime. So we can find out the moment of inertia of the ring about the axis y prime. Then we are going to use theorem of parallel axis and find the moment of inertia of the ring about the axis x prime. So we can say I ring about the axis y prime, its moment of inertia will be given as mr square. Now using theorem of parallel axis, moment of inertia of the ring about the axis x prime, that is given as I ring x prime will be equal to moment of inertia of the ring about the axis y prime plus the mass and the distance. So mass is given as m and distance from the axis is r, so it will be r square. So we can write this as we have, sorry, here it is small r, not capital R, mr square, and the distance from the axis, this distance is also r. So the distance of the parallel axis is also r, small r rather. So we get this as mr square plus mr square. So this will be giving us 2mr square. And this is for one ring. So for both the rings, as the ring are symmetrical, so we can say for two rings, the moment of inertia about axis x prime, let us suppose that is given as I ring about xx prime for both. So we can simply multiply this by 2 and we get 2mr square, which is giving us 4mr square. So for the final condition, total moment of inertia, you can say total moment of inertia about axis x prime, let us suppose that is given as I total about axis x prime will be equal to, we have for the disk plus for the rings, both ring x prime and for both of them. Now it's an easy calculation. Simply substitute the values. So we get this as I total about x prime will be equal to half mr square plus 4mr square. So we got the moment of inertia for of initial condition as well as final condition. Now we are going to use the conservation of angular momentum. Conservation of angular momentum. We can say our I initial about axis x prime, I initial about axis x prime multiplied by the angular velocity omega I will be equal to I total about axis x prime multiplied by omega f, the angular frequency which angular velocity which we are supposed to find out. So we can say from here that our omega f will be equal to, we have I initial about axis x prime multiplied by omega I divided by moment of inertia of total about axis x prime. We substitute the values, we get omega f is equal to, so we get this as I initial is equal to half mr square multiplied by, it is omega I, and here we have half m r square plus 4m r square. Substituting values, we have half, mass is given as 50, radius is our 0.4, and initial is given as 10, so this is also half into 50 multiplied by 0.4 whole square plus 4, and its mass is given as 6.25 and radius is given as 0.2 whole square. And if we solve it, we get omega f is equal to, this will be 8 radian per second. So this is the angular velocity when new angular velocity rather of the system. This is the new angular velocity of the system. A system means system is equal to disk plus 2 rings about axis x prime. So this completes the question. Thank you.